All right, acids and bases. So alcohols can act either as weak acids or as weak bases, just as water can. Show the reaction of methanol, CH3OH, with a strong acid such as HCl and with a strong base such as sodium amide, NH2. Okay, so it helps to draw the lone pairs here, and you can draw the lone pairs around chlorine if you want. So when we're talking about methanol acting as a base, we're talking about a lone pair grabbing a proton. So we can draw our curved arrow notation just as we do with resonance structures. Now we're talking about using curved arrows in a reaction, a chemical reaction. So we start with the lone pair. So this is the tail of the arrow beginning where the electrons are and the head going to where they're going. And in this case, that lone pair is going to pick up that proton. So if it does that, we're going to make a new bond between this proton and this oxygen, which means that the bond between the proton and the chlorine has to turn into a lone pair. So we're going to put that lone pair onto chlorine and make that chloride. And we have a new pair of molecules, CH3OH2 plus, and we still have a lone pair on oxygen here. And then the chlorine is now chloride with its, now it has 8 electrons and a minus formal charge. So notice how we've conserved charge. This is neutral here, both are neutral, and here we have a plus and a minus, so those two cancel out. So charge has been conserved. Now let's look at the reaction between methanol and a strong base. So we have this compound here, sodium, and sodium, we don't have to put sodium in because it's a spectator ion in any of these acid-base reactions. The NH2 minus, we write the lone pairs, so that's the 2 lone pairs in NH2 minus. And now the arrow starts here with the lone pair on nitrogen because this is the base now, and the OH is giving the proton up. So we start on this lone pair and we pull off this proton, so that goes to the proton, and then the bond between oxygen and hydrogen here now goes from being a pair of electrons in a bond to being a pair of electrons as a lone pair on oxygen. And so if we draw the products of this reaction, we have methanol, which has been deprotonated. So we've lost that proton, and now we have O minus, and then NH2 has pulled off a proton. NH2 minus is now NH3 with 1 lone pair instead of 2. So here, notice we've also conserved our charge. We've gone from a situation on the left with 1 negative charge on the amide, on nitrogen, to the negative charge being on oxygen.